In this video, we're going to revisit this problem from the previous video of children's tickets and adult tickets, and I want to show you guys another way which I think is kind of cool, might be even better. Now, the method from the previous video of setting up these systems of equations, this is your fundamental method. So whatever I'm going to show you now in this video is not a replacement for this. You should really know, if you had to pick one, you should just know this one, but you should really know both. So I don't want to bash this method, but you might find this is much more fun to do. Okay, and in fact, I only set up this little space because that's all we're going to need to solve it using the second method. Now, this other cool method might not always work for as many problems, which is why we're not throwing out our systems of equations, because that solves a lot of problems. All right, so what we're going to do here is kind of guess. Let's see, we made $243, but we don't know how many of them were children's tickets or adult tickets. Let's just assume we're going to go to an extreme. So let's say if all 25 were $7 tickets, so we sold only children's tickets, it looks like 25 times 7 would be further away from 243 than if all 25 were $11 tickets. So let's just start with this extreme. Let's say there were 0 children's tickets and 25 adult tickets. That means we made 25 times 11. So if you remember the 11 trick, that's you add the 2 and the 5, so that's $275. So that's why we started at this extreme, because this is kind of close to what we want, but it's not quite there. How far are we off? We are off by $32. So that's our error, right? We didn't match that number. Now here's the key step. So essentially what this means is we don't have 25 adult tickets. We have some number that's smaller than this of adult tickets and a larger number of children's tickets. So rather than trying to directly guess, let's try to swap one for one. So each time you replace an adult ticket with a children's ticket, what happens? That means you take away $11 and you add in $7. So you lose $4, right? So 11 minus 7 is 4, but it's really negative 11 plus 7, which is negative 4. So if we want to drop $32 because that's a negative 32, we're $32 too high. $32 divided by this price differential, the price difference, which is $4. So what's 32 divided by 4? That's 8 steps. In other words, if we create 8 exchanges of an adult ticket for a child ticket, we will get to the exact number we want. So all that means is the real number is 25 minus 8, which is 17 adult tickets, and boom, we're done. So that's 17 adult tickets, therefore must have been 8 children's tickets, because these have to add to 25. So this is not too different from this, but I feel like it's kind of cool, especially if you're in a rush and you need to get this with almost like in your head. All right, I'll see you guys in the next video.